Okay, so next part is finding gradients to functions at any point. So what we've been doing is creating formulas for the gradients, and once you have a formula, we can find the gradient if we know the point, but importantly we can also find the point if we know the gradients, so we can go backwards or forwards. Okay, so copy that and come across. Okay, so let's have a look at this example. Y equals x squared plus 3x minus 1. Find the gradient when x equals 1, or find the point when the gradient equals minus 3. Now note, like for instance, if this question had been written as this, okay, so if rather than y equals, we could add fx equals, the first question would have looked like this, like find the gradient when x equals 1. Okay, so that's what we're trying to find in the second part, in the first part. But in the second part, we would have been finding f dash x equals minus 3, and then we're trying to find the x value. Okay, so just note that question can be asked in mathematical terms, and it's still pretty straightforward. So we've got y, so it's sort of like in English, but if it had been fx, then I could have just said find f dash 1, which is find the gradient when x equals 1, or the gradient equals minus 3, and what was the x value. So they're the sort of questions we ask. So let's do it the way we're going to be doing it. So first thing we do is y dash equals 2x plus 3 using the shortcut, and then we say at x equals 1, y dash equals 2 times 1 plus 3 equals 2 plus 3 equals 5. So the gradient is 5. IA, it's moving up to the right. Okay, part B, I've got 2x plus 3 is the gradient formula, and this time it equals minus 3. So 2x equals minus 6, so x equals minus 3. And have I answered the question? No, because it says find the points. So we've got the x value, and now we've got to find the y value. So at x equals minus 3, go back to the original function. So we've got minus 3 squared plus 3 times minus 3 minus 1 equals 9 minus 9 minus 1 equals minus 1. So the point equals x is minus 3, y is minus 1. So there's the point when the gradient equals minus 3. Copy and come across when you're ready. Okay, so here's another question where you're sort of given clues, but you don't have the original function. So we're told that we've got missing A, missing B. We've got a gradient equals 3 at the points. Okay, so we've got plenty of clues. So first thing we do is we still find the gradient. So we've got 2ax plus b is the formula. Now, at x equals 2, because that's the x value, y dash equals 3, because that's what it says. It says the gradient equals 3. So we say 3 equals 2a times 2 plus b. So 3 equals 4a plus b. And we have to stop because we don't have any more information. So they're going to call that equation number 1. Change colours to make it a bit different. Now, this is simultaneous equations. So we need a second equation, and the second equation comes from the point 2, 2. So at x equals 2, y equals 2, because that's the point. So we go back to the original function. So we've got 2 equals a times 2 squared plus b times 2 equals 4a plus 2b. And we could leave it like that, but all these numbers have a 2 in them. So we've got 1 equals 2a plus b, and that's equation number 2. So now we're going to combine these equations together. So we've got 2a plus b equals 1, 4a plus b equals 3. If I subtract those equations, I'm going to subtract uphill. 4a minus 2a is 2a, b minus b is nothing, 3 minus 1 is 2. So then I've got a equals 1, and then once I've got a equals 1, I can just chuck it in. So b equals 1 minus 2a, which is 1 minus 2 is minus 1. So I've got the answer. Okay. So when you get these things, you'll end up normally with simultaneous equations. That information there is really important because that gives you another equation. So that's how you do them. Okay, come across when you're ready. Okay, so in this exercise, I think these are straightforward gradients, and I think these ones may be finding the letters. Okay, so have a go at those and ask questions if you need to.